Hello guys, I'm Yasir. Welcome to this video tutorial in which we will discuss a coil tubing simulation graph known as working at depth graph. So we'll discuss this graph, we'll understand how to interpret this graph and what is the utilization of this particular graph which is generated during coil tubing simulation, and this particular graph is known as working at depth graph. So let's try to understand its interpretation and the significance of this particular graph. But before going ahead, let's build a continuity with this particular tutorial and our previous tutorial. This tutorial is actually in continuation with our previous tutorial named reaching depth. In that particular tutorial we discuss this graph, and this particular graph is known as reaching depth graph. This tutorial we have already discussed in our previous tutorial. You can find the link in the description, and also the link button will be shown over here, so you can see the previous tutorial known as reaching depth graph. That is the first graph when we run the force simulation of coil tubing. So in this particular tutorial we will see the second graph, that is working at depth graph. In our previous tutorial regarding reaching depth graph, we discussed that this particular graph is a dynamic graph, that it shows simulated weights of coil tubing during running in hole and pull out of hole at each depth. And this particular graph is for a horizontal well, we have already discussed, and this given graph is used to select the required injector head to perform the job. And the given graph also provides a reference weight during job execution, that is we can compare with our actual weights during the job execution. All this discussion we have already discussed in detail in our previous tutorial. So now we'll move to our main topic, that is working at depth graph. So as I just mentioned that this is a second graph, and it is a very important graph while coil tubing job designing. So for this graph here we can see the legend. It is written that maximum pickup at yield, that is 80%. So this red line is actually showing the maximum pickup, also known as maximum overpull, and the second is maximum set down, that is the maximum slack. On the x-axis, if we see, on the x-axis we have the weight, the force weight, okay, and on the vertical axis we have depth. Just like the previous graph, that is reaching at depth graph, this is also a dynamic graph, that it gives us the limits of overpull and slack off at each depth. When we will be at surface, our maximum overpull limit will be this one, approximately 86,000, and our slack off limit will be like 10,000. We'll see the exact number. This particular graph we just started interpreting has been generated for this particular well. So the well for which this graph is generated is a horizontal well with the depth 17,506 feet, and it is completed with 5-inch casing. So as we just discussed that this message will appear when we will perform the simulation. So here it is written that calculations at 17,506 foot, that is this graph has been generated when our coil tubing string will be at 17,506 feet. It is written that the available pickup at 17,506 foot based on 80% of yield strength is 23,496 pound force, that is here when we will be at the bottom. We see that when we will at the surface, our maximum pull will be like 85,000, and will be at the bottom. The maximum pull, maximum overpull which we can apply is 23,496, and at that time the weight indicator reading will then be 74,978 pounds. So simply this red line is basically the overpull at each depth, right? For example, if we are at 10,000, at 10,000 we can apply this overpull which is like 45,000. So it is logical that when we'll go deeper in the well, our overpull limit will decrease. As we can see, when we are at the surface, our overpull limit is more. When we will go deeper into the well, our overpull limit will decrease. So this will be our job limit. The minimum available pickup is 22,676 pound at 17,000 force. Here we can see in this graph that this graph is then shifted back. That is the minimum point is this one, 17,000. So while execution, so our limit of overpull will be 22,676 pound force. And for this blue line, which is basically set down line, the available set down force at 17,506 foot is minus 6 pound force at the end of the string. The weight indicator reading will be 19,647. That is the slack of which we can give maximum without any special bottom hole assembly is minus 6 pound. That is, we cannot apply bottom hole force, that is set down or slack. So simply, just to summarize, this is the overpull graph and this is the slack off graph. These are our limits. We cannot exceed this red line and we also cannot exceed this blue line. For overpull we cannot exceed this red line, and for slack off we cannot increase this blue line. Similar to reaching depth graph, this graph is also a dynamic graph. That is, it provides the values at each depth. We have already discussed that this is a dynamic graph, that it provides value of the overpull and set down at each depth. Application of a graph, we can easily conclude that the given graph known as working at depth graph is very useful, as it provides us with the job limits with reference to our coil tubing string, that is the maximum slack off and maximum overpull we can apply. These values are then useful to design the fishing job, milling job, release our coil tubing in case we get stuck. So these are the limits, that is the maximum overpull and maximum set down are requirement while we are designing the job, coil tubing job. For example, during fishing job we need how much overpull we can apply to retrieve a fish, and in milling job we need a weight on bit on the mill motor on the mill bit. So we need these parameters while job designing. Similar to reaching depth graph, this graph is also a dynamic graph and it provides the values at each depth. So that was the discussion about working at depth graph. Now I will end this tutorial with a question for you guys, that what will happen if we cross these limits. I just mentioned that we cannot exceed these two limits. This is the slack off limit and this is the overpull limit. We cannot exceed these limits. So my question is that if we exceed these limits, that is if we move beyond these limits, if we apply more slack off than this minus 10,000, what will happen to our coil tubing string? Similarly, if we apply more overpull, what will happen to our coil tubing string? And the second question is that if we just see this legend, here it is written that maximum pickup at 80% yield. That is, for this overpull limit he have used the yield 80% yield. Why doesn't use in this maximum set down? Why 80% yield is mentioned with the red line and not blue line legend? So I'll be waiting for your response for this question. So thank you very much. See you in the next tutorial.